Lean Six Sigma White Belt, Chapter 3. Lean Six Sigma Foundation Concepts. So before we put anything into practice, it's important to first understand a couple of key principles. So let's move on to learn more about Lean Six Sigma by understanding the foundational concepts unique and shared for both methods. Lean foundational concepts. We'll start with Lean. As you follow along with the descriptions over the next few pages, you can fill in the graphic on page 12 of your workbook, and you can take notes there as well as we progress. As we go through each of these 5 Lean foundational concepts, we'll ask you to complete a practice activity on page 13. So for this section, you'll go between pages 12 and 13 as we talk. There's a lot of misconception about the principles of the Lean philosophy. In the past 30 years, the term Lean was implemented in many ways within organizations, and you will find many variations in literature and online. Here we will cover the basic terminology and principles of Lean. These terms identify elements that are critical to a Lean operation that results in operational excellence. They are value, the value stream, flow of the process, the concept of pull instead of push, and the relentless pursuit of perfection. Let's go into a little more detail on each of these.
Value is a term that is used in so many different ways and contexts. In Lean, this refers to the practice of examining each task or activity in a process and then determining whether that step actually adds value from the perspective of the customer. This can be a very surprising exercise when we realize what proportion of our activities don't have anything to do with our customer.
A few important terms that go along with the concept of value are value added, non-value added, and waste. Value adding. It's any step in the process that changes the nature, shape, or characteristics of a product or service in line with what the customer wants. Typically 5 to 10% of all process steps. So if we are using our phone to make a deposit into our bank account, an example of a value adding step would be the step that puts the dollars into my account. But all the previous steps that led up to that, logging in, checking that I'm not a robot, answering the security questions, the post-deposit survey, etc., would be classified as non-value adding. So non-value adding. Any activity that doesn't add value to the product or service. This is everything that is not value adding. Steps or tasks that add costs or time without adding value. These steps may be essential, they may be necessary to the job, but they are still non-value adding. And there are 2 types of non-value adding steps. These are necessary. These are called value enabling. For example, putting on PPE, compliance with regulations, workstation preparation, checking progress, etc. And a second type of non-value adding steps is waste.
Waste in this context refers to process waste. This term doesn't refer to physical waste, but refers to any step that costs time or money without adding or enabling value. Learning how to recognize the 8 wastes and having the skill to know how to remove or minimize this waste is one of the ways that we improve our processes. Some examples of waste that you might not recognize in your own process are things like waiting, moving things or data from one place to another, overly complicated steps or logic, anything having to do with a mistake or a defect, that is, creating a defect or a mistake, finding one, or fixing one. Every activity in our process is either value-adding or non-value-adding, and the skill is knowing how to recognize and respond to this waste. On page 13, you'll see a rectangle near the top left that says value. In this section, you need to review the 9 various steps that are a part of this process of making and delivering pizza. Review these steps to determine whether they meet the criteria to be considered value-adding. There are 3 specific criteria that must be met for a step to be considered value-adding. Those criteria are, number 1, the step must change the unit. The unit is what's ever being worked on. In our case, it's a pizza. So criteria number 1 is, does this step change the pizza? Criteria number 2 is that it must be done right the first time. This means that if the step is to find or fix an error, it's automatically non-value adding. And criteria 3 is that it has to be important to the customer. This means that if a step that we're doing for our own purposes or the internal needs of the business, it's not considered value adding. Take a moment now and see if you can identify the value adding steps. When you're done, you can flip back to workbook page 11.
Next is the concept of the value stream. If we understand what a value adding step is and we look at the chain of those value adding steps in the process, we can get a picture of the value stream. The value stream identifies the vital steps in the process and does not include the unnecessary steps that results in waste. The objective is to optimize the flow of work and getting to value more efficiently and effectively. A value stream is a set of all the steps from the start of your process all the way through to the result your customer expects. The aim is to eliminate or minimize as much non-value adding as possible. Any waste removal or reduction will contribute to a better work environment, quality, service, and costs. In this example, we are illustrating the proportions of value-adding steps in the process of a hospital admission. We've all been there. The blue steps indicate a value-adding step. The light blue might be considered value-enabling, and the grey boxes are non-value-adding. From left to right, we have arrival, entering of the patient info, and then a wait. Identifying the waits in the process is a very important step in understanding the value stream, especially from a customer perspective. After the wait, there is preparation or setup and then triage to prioritize the doctor's queues of patients. After that, we have a lot of time spent finding supplies, reprioritizing patients, waiting, transferring, and moving. Questions, corrections of all kinds of activities. Then the patient is treated. This is usually a very small amount of time in relation to the entire experience. After the treatment, there is more waiting, sorting, moving. And then the discharge followed by more waiting, escorting out, and end of the process. One of the methods used in process improvements is to perform a time and value analysis to understand how we can create a greater proportion of value-adding steps by minimizing the wastes. Increase efficiencies while increasing quality and service. It can be a great challenge, but it is so worth it and can be a lot of fun.
On page 13 of your workbook, you'll see the value stream section. In this section, see if you can break down the process that you work in into 5 high-level steps. These steps should cover the process from start to finish at a very high level. For example, if I work at the front desk of a hotel and my job is to check guests into the hotel, my steps might look like this. Greet the guest, gather ID and credit card, assign the room, give key and property info, and lastly, say goodbye. Take a moment to jot down your high-level steps. It doesn't have to be perfect, but just get your thoughts down. Once you've identified your high-level steps, you'll probably have identified at least the major steps in the process, which usually align to the value-adding steps. If you think about it, there's usually a lot that goes on in between those high-level steps, and all these tasks and activities that go on in between is where we find many non-value-adding steps. This leads us to flow. Think about water flowing through a pipe. We want the water to flow continuously and come out fast and clean. A clogged pipe would cause the water to become sludge, moving slowly, sticking to the pipe, and getting worse over time. A process that moves seamlessly and swiftly from one task to the next has good flow. We get good flow by eliminating steps in the process that cause interruption, backward movement, like having to go back for corrections, approvals, rework, any kinds of delays or defects.
One of the tools that is used to visualize flow is called a spaghetti map. It's one way for us to get a picture of what we can do to improve the process flow. The types of changes that improve flow would be things like shortening the distance traveled, like from your desk to the printer or supply room, improving the physical layout to make sure that people or equipment are in the order in which the process flows, move sequential activities closer to each other, remove redundant steps, reduce time that any process step is waiting for the next step, documents waiting in a queue, people waiting on hold, etc., and eliminate interruptions where possible. A simple example from one of our customers was improving the distance traveled to the printer. Very simple, but it was interesting. Two work groups were analyzed. Group A was 92 feet away for every trip to the printer. Group B was 696 feet away for every trip to the printer. They definitely got their steps in for the day. There were a combined of 120 trips to the printer per day, which equaled 4,656 miles per year. At a walking pace of 1 mile per hour, that works out to around 582 days per year of unproductive, non-value adding time. That's equivalent to more than 2 full-time people just to walk to the printer. Identifying opportunities to improve flow gets our product or service to the customer more quickly and provides a much more productive and pleasant work environment for employees and teams, which creates a stronger organization.
On page 13 of the workbook, find the activity in the middle of the page for your flow activity. This activity has 2 parts. You'll need a timer for this, so get your phone ready for timer mode. For the first part, you'll use the first 2 lines. Once you start the timer, you will write the cost of interruptions on line 1, and you'll write the numbers 1 through 22 on line 2. When you complete those 2 lines, stop the timer and record your time on the right. For part 2, you'll do the same thing, except you will alternate writing on line 1 and line 2. So you'll write the first letter on line 1 and then the first number on line 2, and continue alternating until both lines are completed. Record your time when you're done. So you completed the workbook activity on interrupted flow. The results here are pretty predictable. Even though you completed the exact same work, the second set was an example of interrupted flow. We become very used to interruptions as we are working and sometimes don't even realize the cost of these interruptions. When our workflow is interrupted, time can increase. In our practice activity, it can double. Typically, the quality of work decreases. There's a lot more stress involved in the starting and stopping action, and in the end of the day, it's just not as enjoyable. Part of understanding flow is to really understand the cost of your poor flow.
Pull is our next concept. This is not a question of whether we physically push or pull materials or supplies down a hallway. That's ergonomics. Pull in Lean is the conceptual pull of resources as information, discussions, decisions, tools, expertise, equipment, when needed by the next step in the process. Pull is making resources available when needed by the customer or the next step in the process, not when we have the resource ready. What does this mean for your business? This means we need to think about pull as the next process step or customer pulling resources that are needed. Doing work when it's needed rather than doing it when it's convenient or when we happen to have the capacity.
Let's think about an example in a hospital, which maybe we can all relate.
The day that you think you're done fixing your processes or that you know it all is the day that you stop learning and growing, unfortunately. It's the day that you start regressing and going backwards. This has been proven over and over. The most successful organizations and people who we've met over the years all had one main thing in common. They never stopped learning or looking for ways to improve. They are continuously interested in looking for better ways to do what they do. When you view your workplace with an open mind, surprising things happen. You make unexpected discoveries that will help you work smarter, faster, and stronger. This doesn't happen when you're just doing the same old thing every day. When you think that your way is the best and only way, then your mind remains closed. With this mindset, it's easy to become threatened by new ideas or suggestions.
With lean thinking, we go into situations open-minded with the attitude that no matter how much you know or how much you've already improved, there's always a better way. This is the relentless pursuit of perfection. The goal of perfection will never be reached, but it's essential to strive for nonetheless. Lean is not about getting people to work hard by dangling the unattainable reward of perfection in front of them. It's that Lean strategies freely acknowledge the fact that the improvement efforts will never be complete. It allows each project to celebrate each victory, no matter how large or small, on the road to perfection, even while understanding that the road will never end. It presents a constant challenge which people can work to overcome, and along the way, there will be plenty of rewards available for anyone who works for them. So we've covered the foundational concepts and some key terminology of Lean. By this time, you should be gaining insight into how these principles can result in operational excellence. Let's take a look at the basic principles of Six Sigma, where you'll see some differences and also some commonalities.
Six Sigma, like Lean, is a method for process improvement. Technically, the term Six Sigma is a measure of perfect process. That is, as perfect as statistically possible. And in a measure that reminds us to continually strive for perfection, Six Sigma as a method includes these core concepts: focus on the customer, the reduction of defects and variation in the process, the visual management of performance, and taking action to continually improve. We'll explore each of these in a little more depth.
One of the early steps in a Six Sigma improvement project is to identify the process that we are focused on, and then identifying the process customers. The term customer in this sense is referring to the recipient of your process output. This can be a person, a department, or even a database. It may be internal or external to the organization. If the process that you are focused on makes labels, and these labels are then sent to the department that puts the labels on jars, then that department is the customer of your process. Some processes have an output that goes directly to a paying customer. Either way, identifying your process customers is a key first step because it sets the trajectory for the rest of your improvement work.
A customer is the most important perspective to understand. The customer is not dependent on us. We are dependent on the customer. The customer is not an interruption in our work, but is the purpose of it. He is not separate from our purpose and our process, but part of it. We are not doing the customer any favor by serving him or her, which is a common attitude, especially with internal customers. We need to understand that our customer is doing us a favor by giving us an opportunity to do work for them.
The customers of the process are the only ones who can define what a good job looks like. For this reason, your customers know more about what your process needs to deliver than you do. You cannot define it apart from your customers. What's a defect? What's considered on time? What is easy to use? These are all aspects of your process that we must understand from our customer so that we can prioritize our opportunities for improvement. On page 15 of your workbook, you'll see the diagram on the top half of the page. Refer to page 10 of your workbook and find boxes 3 and 4. There you'll find your own description of your process customer and your thoughts on their needs or complaints. Keep that person or group in mind when you complete the activity on page 15. How would your customer define the attributes listed? What is their definition of defect-free? What about on time? What does complete look like to them? What do they need in order to be considered easy to use? And what type of service do they expect? Pause this presentation while you do this work and take your time to get it as complete as you can.
We've just had some time to think about the kind of things that matter to a customer. Some generic examples of what customers care about might be: how long will it take? What percentage of the time will the system be down? How much will it cost? How many French fries will come in my order? These are some simple examples of elements of a product or service that will contribute to the overall satisfaction of that customer. So if you go into a restaurant and your meal comes in 15 minutes, you get a nice generous portion of fries on the side and the temperature of your burger is just right. If you go back to that same restaurant and your food takes 25 minutes to arrive, you get a small pile of old fries and your burger is lukewarm. You have experienced the downside of variation. While variety can be good, process variation, especially if it's unpredictable, is not good. Too much variation is a sign of defects. That is, aspects of your process that are unacceptable to the customer. A main concept of Six Sigma is understanding the variation in your process and then reducing defects and reducing that variation so that your customer knows what to expect every time. This also means that the business has a much more predictable operation. The topic of variation can get a bit complicated, but as a core concept, it is important to start thinking about your process and what type of variation might your customer be experiencing.
Let's go to page 15 of your workbook on the bottom half of the page. Using your description of timeliness on the top portion of the page, let's put a title on the chart and bottom of the page. This chart is called a histogram, and it's a tool used to visualize and understand variation. We're not going to create a technical histogram here, but we are just using some basic info to help understand the idea of variation. In this example, let's say that your customer is a customer of a pizza delivery process. You might label this chart Pizza Delivery Time. After you've labeled the chart, let's think about the average time. So in our pizza example, what's our average delivery time? Maybe it's 20 minutes. You don't have to be exact with this practice activity, but just use what you know, or you can even create a made-up example for this activity. Put the average time in the center box below the chart. Now, think about the fastest that we ever complete our process. So in our pizza example, what's the fastest we ever deliver pizza from order to delivery? Let's say that's 15 minutes. Now on the right side of the chart, what's the longest it can take, the slowest time? For pizza, let's say it's 75 minutes. The last part of this practice is to draw a star where you believe the customer's expectation is. So in our pizza example, and our customer's expectation is no more than 30 minutes. We draw a star on the line where the 30 would be. This visual allows us to see a better representation of the variation in the process and not just the average. The customer feels the variation. They don't feel the average. The histogram is a tool that we teach in Greenbelt training. Here, we're just using the concept for a little visual understanding.
Visual performance management is a practice that allows your process to talk to you. It tells you what is working and what's not working, but you have to listen. Like the dashboard of your car, it provides early warning signs and lets the team know where to focus and when to take action. Just like your car's dashboard, you'd expect to see certain elements that are monitored. These include factors such as safety or security, quality, cost, delivery, or timeliness, and definitely people. The benefits of visual performance management is that it provides a graphic display for people in the process to communicate useful and productive key performance indicators and information, detect and respond quickly to issues, make data-based actions and decisions, understand relevant changes and patterns in data, and coordinate with other functions and departments. A consistent use of visual performance management throughout our organization facilitates organizational coordinations while allowing department-specific uniqueness. While each department or function will have various challenges and different things that they monitor, they will have a common tool that will allow greater communication. On page 16 of your workbook, use the top portion to come up with ideas or options of what you think you need to monitor in your process. What could you measure to monitor security or safety? How could you measure quality, cost, timeliness? And what about people? There are usually many options of potential ways to measure, but doing this right takes a lot of practice and skill. You'll see a simple example from a pizza delivery process. Take a pause to fill in some ideas for your process.
As we just learned, visual performance management is one of the tools used to direct us to when and where to take action, and a core concept of Six Sigma is continuous improvement. That is, ongoing, structured actions taken to improve a process. to improve quality, speed, efficiency, safety, the customer experience, employee engagement, or whatever we prioritize as most important to our customer, employees, and our business. While there are various techniques for process improvement, Six Sigma relies on tried and true methods that have been around for decades. Six Sigma takes a handful of proven methods and trains a group of in-house technical leaders, those are green belts or black belts, to a high level of proficiency in the application of these techniques. For sure, some of the methods used by black belts are quite advanced, but the tools are applied within a simple performance improvement model known as DMAIC, an acronym for the steps in problem-solving process: define, measure, analyze, improve, and control.
This structure is critical foundation to the success of improvement efforts because of the discipline it instills. Before we begin solving a problem, we need to understand it, to define the process, the customer, and the problem. We then understand and measure the problem or opportunity. If you decide that you have a New Year's resolution to get healthy, for example, you define that goal and then come up with a way to measure your starting point. Maybe you'd measure your weight or BMI or blood pressure. That's the baseline measure, so you have your starting point. Then the analyze phase is a time where we understand all the different factors at play. Which factors have the biggest impact on your goal? What about our routine have we not noticed before? How do all these factors interact? When we have analyzed our process and really understood all the different factors, then we can go to the improve phase, where we can now, with confidence, create some really innovative options for improvement. After testing and piloting our new way of doing things, the last phase is there to ensure that all the work that we did to improve doesn't fade away. We want our hard work and great results to be sustained.
Improvement using the DMAIC cycle allows us the time and space that we need to do each of these critical phases very well. Without this structure, you can imagine that most people would jump right into solutions without truly knowing what it is that should or could change. And many of these solutions that go into place do not have the expected impact. Many times, in fact, they can make things worse. DMAIC applies to all improvement projects, big or small, in any type of process, and it's the core method of continuous improvement.
We've noticed over the years that many people go through courses or read books about Six Sigma, and yet they have no idea what the term or the symbol actually means. So we're going to take a few minutes to explain the symbol and meaning to you today.
The Six Sigma philosophy aims for virtually error-free business performance. The symbol for sigma that you see beside the big six is a letter in the Greek alphabet used by statisticians to indicate the variation or standard deviation in a data set compared to customer expectations or requirements. So if I buy a bunch of hamburgers that should weigh a half a pound each, and they all weigh different amounts, anywhere from an eighth of a pound to a pound, that's a lot of variation. And to a customer, that's no good. A Six Sigma process would deliver all hamburgers right at that half pound, virtually every time. A company's performance can be measured by the Sigma level of their business processes. The higher the Sigma level, and 6 is the highest, the better the process. A higher Sigma level means less variation, more predictability, and greater precision.
Please take notes on page 17 of your workbook for the next couple of concepts. So the Sigma level can be calculated in a few different ways. The table at the top of the page shows that we can calculate Sigma either by measuring the proportion of defect-free products or services, or by counting the number of defects per million opportunities. Let's say that you are buying a product online. An opportunity for a defect would be anything that could go wrong with your order, like the wrong address, wrong payment amount, wrong color, wrong size, etc. In order to determine the Sigma level, we would measure the average number of defects per order, and then we'd extrapolate that to 1,000,000 opportunities to determine how many defects would there be given 1,000,000 opportunities. The defect-free percentage, or the defect per million opportunities, can be used to calculate the Sigma level.
The charts on the bottom illustrate another way to calculate Sigma. We won't get into the calculation here, but we'll touch on the concept. Let's use an example of restaurant meal delivery time. In each of the charts on the bottom, you see a red vertical line. This indicates the customer maximum tolerance or expectation for time it will take for their food to come. Let's imagine that the customer expectation for food to be on the table is 20 minutes. The chart on the left shows a wide variation. On the left side of the graph, we have some meals that were delivered very quickly, but everything that goes past the red line indicates meals that were delivered late, past the customer requirements. This is a restaurant where you might get your food in, let's say, 5 minutes or 35 minutes. The graph on the right has the same customer requirement, but all the meals were delivered well within the requirement. No late meals and no meals served too quickly either. It's a little more complex to understand, but the calculation of sigma level identifies how the variation in the process compares to customer requirements. A 1 sigma process means that we are, in this example, late a lot. A 3 sigma process means that we're just meeting that requirement. And a 6 sigma process means that we are well within the customer requirements. Traditionally, companies accept 3 or 4 sigma performance levels as the norm, despite the fact that these processes create between 6,200 and 67,000 problems per million opportunities.
6 Sigma identifies and eliminates costs which provide no value to customers. Waste costs. For non-6 Sigma companies, these costs are often extremely high and usually unknown. Companies operating at 3 or 4 Sigma typically spend between 25 and 40% of their revenues fixing problems. This is known as the cost of quality, or more accurately, the cost of poor quality. Companies operating at 6 Sigma typically spend less than 5% of their revenues fixing problems. The dollar cost on this gap can be huge. GE estimates that the gap between 3 or 4 Sigma and 6 Sigma was costing them between $8 billion and $12 billion per year.